Good morning, everyone. Can you all hear me okay? Yeah. All up the back, everything is good? That's great. Well, wow, we're going forwards automatically. Welcome, everyone, to my talk this morning. My name's Trent, and I'm going to be talking about easy MySQL server performance tuning. And very first, I was just going to talk briefly about who I am. So my name is Trent. As you know, I'm based right here in Perth in Australia, so it's great to have LCA back in my hometown. And I first got involved with open source and Linux and that sort of thing about 2002. So I joined the local Perth Linux users group and started using Linux and got very excited and started doing all sorts of things. And that led me about 2003 to get involved with some systems administration and support with a local non-profit ISP called Burst Networking. So that was a volunteer role, and it was great to start using these new skills that I'd learned and actually get out in the real world, and was probably one of my earlier exposures to MySQL as well. In 2003 and 2004, I attended linux.conf.au and actually did for many years, right through to about 2009. And I've also done a number of talks on topics such as IPv6 and also the project Avahi. So Avahi was another project I was on the team for, and it's a Bonjo-compatible service discovery stack for Linux. And the lead author on that project, Leonard, is actually here at the conference as well. And then in 2007, I joined MySQL as a technical support engineer, and I remain in that role today, although we've actually changed companies a couple of times. So I originally started working for the company MySQL. They were then acquired by Sun Microsystems, and obviously now by Oracle. So my current role is a technical support engineer at Oracle. So a quick overview about MySQL. I'm guessing most people in here already know what MySQL is. Who actually uses MySQL in their sort of day-to-day? Pretty much everyone. Yeah, that's not really a surprise because it is one of the leading databases in the world. It's the most popular open source database system. Certainly at least in use for applications and that sort of thing. There's some argument now that SQLite has taken over that number by virtue of being deployed on nearly every phone on the planet. So there are hundreds of billions of SQLite installations, but that's more of an embedded usage than it is usages on websites and enterprise applications and that sort of thing. It's the leading database for web applications. Nearly any website you visit these days is often using MySQL, and 9 out of the 10 sites in the top sort of 10 sites on the internet are also using MySQL in some capacity. It's estimated there's over 15 million active installations, which is a pretty big number. And most importantly, it is open source software. It's GPL 2.0 with a free license exception. And the lead development is now done by Oracle. Since Oracle has been stewarding MySQL development, there's been 2 major releases, MySQL 5.5 and 5.6. And I think there's a pretty good opinion that MySQL has been improving in leaps and bounds in that time. The scalability has gone up immensely. There's been lots of nice new features that people are enjoying. And I just wanted to refresh everyone that MySQL is still very much an open source project. You can still get it for free and easily, still available under the GPL, and it's still very much active. But there obviously has been a lot more competition in the database space in the last few years, not just in SQL. You've obviously got PostgreSQL's probably one of the more popular big competitors to MySQL directly, but now we're getting a lot of other databases. So we're getting NoSQL style databases, which are much simpler sort of key value access styles of databases than they are a full SQL compatible database. And so it's becoming a lot more popular, especially in the sort of systems that have immense scale, perhaps more than just your basic website with some thousands of users. This keeps moving on me, that's all right. So MySQL 5.5 had some new features. There are a lot of scalability improvements, which people are finding has helped a lot. Multi-core scalability in general has been improving with every MySQL release. So 5.0, 5.1, 5.5, the number of cores you can scale to has been getting better and better. Because back when MySQL's some 20 plus years old now, when we only had 1 CPU core, and turns out making things run on 16 or 64 CPU cores is quite hard. In MySQL 5.5, we switched to using InnerTV as the default storage engine. If you're familiar with MySQL, there's an older storage engine called MyISAM, which is a non-transactional storage engine. It doesn't have crash safety and those sorts of features. Whereas InnerTV is the storage engine that's been around for a long time, but offers that crash safety, ACID compliance, and is what most people are using. There was semi-synchronous replication was added, so the ability to ensure that when you're replicating from one MySQL server to another, you want to make sure that that latest update has made it to another server before it's returned back that that commit was successful. IPv6 support was finally fixed. That was a big one for me. If you've known me for a long time, I've been involved in IPv6 since sort of early 2000s, and it was finally good to see. I don't know why that didn't happen until more recently, but IPv6 is now properly supported for connections and that sort of thing. There was some metadata locking added, which just basically ensures that tables don't change out from under you when you're doing things. And the performance schema. So I'm not going to talk about performance schema today, but if you're actually getting down in depth and you're looking to tune specific queries and much more intense sort of performance tuning, it's a very powerful tool for getting information out of MySQL. In MySQL 5.6, we've got more scalability. That's great. InnerTV had persistent optimizer statistics added. So a lot of people found that if they restarted their server or they reloaded a table, that their queries started behaving oddly, and that's because the statistics it uses were just randomly fetched every time the server started. So there was some persistency added for that. A memcached API was added, so we don't need like NoSQL or a memcache. We can just actually use the memcached API to access tables within MySQL. So that's really useful where you've got a traditional system using MySQL and you want to store data into it, but then you want to get very easy access through memcache to just grab a specific key and get back a value, and then skip all of the overhead of the SQL connection layer in doing that. Some more support by partitioning was added, and multi-threaded replication slaves were also added, which when you replicated in MySQL traditionally from one server to another, the whole stream of updates was sent in order, but you could only replicate those statements one at a time. And so that was actually slower to run than it was on the original source server, because you had to do it in order. They couldn't be done in parallel, so they've now improved that. So this overview that I'm going to give this morning is a very simplistic overview. It's not going to teach you everything. It's quite probably wrong if you're trying to run Facebook on 3 servers in your back room. But out of the box, MySQL needs a few things to be changed, and a lot of people don't realize that. So I'm just going to go over some of the basics to sort of give you an idea of where to start. So why do we want to tune MySQL? Well, the fundamental reason is that MySQL does not automatically scale to server specifications. So when it starts up, it doesn't look at the host and say, how many CPUs have we got, how much RAM have we got, and tries to figure out maybe some of the best settings to use to take advantage of those resources. Yes, a question? Why not? Why not? That is a fantastic question. Why does not MySQL do that? There's a couple of reasons. Number one is it doesn't. There's actually been there's been some work in MySQL 5.6, which has just come out in the last year. It now actually attempts to auto-size quite a few values. Not all of them, but they've started on some of that work. But the other side of that is you don't always... Excuse me one second, I just need to get rid of these slide timings. Well, for that, basically, you don't know what else is running on the server. So if you've got a dedicated MySQL server only, and you know it's going to be using InnerTV, it's going to go, great, I can use 80% of the system RAM. But if you're trying to run MySQL and a web server, and that happens to be the desktop you're using in your bedroom, you don't want it to use all of your RAM. So in some cases, it can't actually know for sure. But it certainly could do a better job at auto-sizing. Yes? Yeah, you could maybe ask what the environment is. Yeah, so it certainly could do a better job at that. And you see some projects, I know in particular ZFS on Solaris, their main, from the start, was you shouldn't need to tune it, it should figure itself out. And they've done a better job at that, but inevitably you find a lot of the time you still need to tune things for different workloads. And that tune the server is to set some of those values that we need to set based on our workload, based on how much RAM we've got, and those sorts of things. Unfortunately, what most people then realize, they think, oh great, I can tune the server, there's like hundreds of options I can change, I'm going to go and change all of them and get everyone right. And invariably they like to just set things to bigger numbers. That's not always the best way to go about things, and most people end up ruining their server performance in the process. So we need a bit of a balance, and when there's so many options, I'm trying to give basically a small guide as to which ones you should be looking at changing while we wait for my computer. Yeah, so the performance schema was added, and basically, traditionally with MySQL, and that'll come up in a second, but you could get basic statistics from the server. So it'll tell you, numbers of queries run that did a full join versus used indexes, and how many times we've done a sort merge while trying to sort things. And Then from there, they added query profiling where you could run a Civic query and then get some information about how long each of the steps took. When was it scanning the table? When was it updating the query cache and that sort of thing? But it was all a bit pieced together. So they've added in performance schema, which gives you you can plug right into the server and find out exactly what this query did, what kind of resources it was using, how many times it ran certain algorithms and all that sort of thing. So it's a little bit outside the scope of today's because it's a bit more in depth, but if you need to do some serious performance tuning, have a look at performance schema. There's some really awesome stuff that you can do with that. I suppose by any small chance someone knows how to kill the slide timings from. That's all right, we'll deal with it. If it moves on and you get confused, please let me know. And the display's in the wrong resolution. So, looking at some of the default settings that MySQL comes with out of the box, we can see absolutely why we might want to do this. The amount of RAM it will try and use for itself, depending on the number of connections, is maybe 128 megabytes. These days we've got systems that often come with 4, 8, or 16 gigabytes, so we should try and make some more use of that. The maximum number of connections recently was raised to 150, and many people find that that's not enough. The numbers of tables that we're caching, that sort of thing, are only a few hundred. And as I said, the memory data we're using caching is only 128 meg, which is just far too small in most cases. So let's take a look at how we can actually configure the MySQL server. So the first thing is it has a configuration file like most good programs, and that file is called my.cnf. And its on-disk location varies wildly depending on how you installed it and what distribution and where you got it from. These are the most popular ones. This is where it is on Debian and Ubuntu. This is where it is on Red Hat, and this is where it is if you install it from the MySQL website, and it might be somewhere else. You also need to check all of them because it will sort of start combining them, or depending on the version, might change which one it looks at. So you definitely want to hunt around the file system and make sure you have the right my.cnf and the changes you're making are actually happening. This is what it looks like. It's a standard INI format file. This is just a simple little example. This is not really relevant, but you've got your basic sections and your basic sort of, here's the variable we're setting and that's the value we're setting it to. We can expect this information at runtime. So if you, was that a question, sorry? Nope. So if you connect to the server, you can use the command show global variables and you can actually check what value it's actually running. This is useful because sometimes people change these settings at runtime, so you want to actually make sure that the setting you think is set in the config file is actually the one that's in use. So that's show global variables. That's quite useful. And if you want to check a specific setting, you know the name of it, then you can use a like and then the name. And that will only return back the one, so you don't have to hunt through 400 rows to find the particular setting that you're looking for. As well as changing them in the configuration file, variables can actually be updated at runtime through the MySQL client. So we can run a command to set a variable. It's important to understand that there is two scopes of variables. We've got global variables and session variables. For the most part, when you make a connection to the MySQL server, it grabs whatever the current global default is and it sort of clones that value into the session. And from then on in the session, you can actually change it. So if you know maybe a variable should be more optimal for a query you're going to run, you can actually change that within the session. The trap with that is if you change the global default, it won't actually change any of the currently connected connections and it won't apply until they reconnect. So that's something to be aware of. If you've got like a long-running application that doesn't close its connection or uses a connection pool, changing your default isn't actually going to get it to pick those settings up until it reconnects next time. If you run one of these commands, a set global or set session, it does not update the my.cnf file. So that change will only be persistent until the server restarts. So if you want to make a change dynamically without restarting the server, you need to both run the set global command for it, as well as update the my.cnf file. And then when you do that, you want to make sure that you haven't made some kind of syntax error so that when the server reboots at 2 a.m. you don't get woken up because it can't now read the file because you never actually tested it. So that's just something to be very aware of. There's a fantastic reference in the MySQL documentation online as to all of the variables that you can adjust. The website for it is here, and these slides will be available on the conference website, so you can get these. And it basically just has every single variable name listed. It then tells you, is this a global or a session variable? So it's something, you know, does it affect only the session or does it affect everything globally? And it also tells you whether it's dynamic. So not all variables can actually be changed with a set command. Some of them you must restart the server. And so that reference guide will tell you whether you can do it. You can also just try it and it will tell you whether you can set it or not if you're not sure. This is just an example of the documentation. So if you want to look at a Civic option and you're not sure what it does, you can click on its name and it will zoom you down to a little section. And it will both tell you what it does, but also quite usefully, it tells you what the default value is. So if you're not sure what's being applied, if it's not actually in the config file, and most config files are quite small by default, you can go check the documentation to see what default is applying to you there. Or you can also use that show global variables command. The other thing we can check on is show global status, and this will tell us all sorts of interesting numbers about the MySQL server. You'll need to learn to interpret these, and we'll talk a little bit later about some of those ones to look at. But if you run show global status, you get a nice big long list of numbers that tell you all sorts of interesting things. So I'm going to go through a quick example case of why we might want to change some of these settings. Has anyone here ever seen this error message from something using MySQL? Pretty much everyone. Usually at the most inopportune time, your website's been put out on a press release or something's happened and you've been woken up at some insane hour and you've seen too many connections. So you do a bit of looking around and you figure out that we can check the number of connections to the server. So the maximum number of used connections was 150. And we've checked the global variables and we can see that, in fact, that is the number configured to the server. So the server's max number of connections is 150, and we probably need to raise that. So you've done some Googling around, and you figured out that, let's change it to 1,000. That sounds like a good number. We couldn't possibly use more than that. Let's change that. So you change it to 1,000, and then you restart the server, and everything seems all fine for a couple more days. 2 a.m. rolls around again, and you look at your server and you find this. Who's seen this before? Yeah, so if you haven't seen this, when your system runs out of memory on Linux, it needs to get some memory from somewhere so it can keep doing things. So it starts hunting around the system for something using memory and kills it to get all of its memory back. Because MySQL often is using the most amount of RAM on your system, it's very often the target of this particular attack, and so your MySQL server often ends up being killed. Fortunately, the default configuration for MySQL, it ships a little angel process called MySQL safe that will then restart MySQL for you. So most people, it'll kill it and it'll come back and they may not notice. But you can also have MySQL be the culprit and end up killing something else. So a lot of cases you've got Apache web server and MySQL on the same system. Your MySQL needs some more RAM and it ends up killing your Apache web server and your whole web server stops. So that's not particularly much good. So the biggest thing to remember is that bigger numbers are not better numbers. This is an example of a configuration file I've seen in the wild. You may not know what any of these numbers mean yet, but the default values for most of these things are in the kilobytes, maybe 128 kilobytes or 256 kilobytes. And they've gone through and thought, well, 32 megabytes sounds good, 128 megabytes must be good, 2,000 maximum connections, what could go wrong? If you see this in your configuration file, there's a good chance that you're probably not doing it right. And now we're going to talk a little bit about what we should set those to. Yes, a question?
How much housekeeping has to be kept for each connection? Like what kind of stuff has to be maintained in memory?
Yeah, so the question is what kind of housekeeping is done and kept in memory for each connection? That's a little bit what we'll talk about, and in fact I have a slide on that right here. Up here, there's better documentation on this in the manual, and I apologize, it's a little bit small to read. This is an example of some of the settings up here. These are called global settings. So some of these memory buffers, such as the key buffer and the query cache, those are allocated once for the whole service. So you set it to 128 megabytes, and it uses 128 megabytes. But a lot of these buffers are also allocated for each connection, or maybe each query that runs inside that connection. And these ones are listed down here. And so, you know, this sort buffer size and read buffer size, and you can usually tell because their settings are usually maybe less than a megabyte or so. those are allocated for every connection. And this is why I end up running out of memory. So in this great little calculation, we've got 2,000 connections maximum for the server. We've set all of our buffers to wonderful numbers like 32 and 128 megabytes. And the maximum theoretical memory usage for MySQL is 400 gigabytes. It is possible to buy a server with 400 gigabytes these days. It wasn't a few years ago. It is possible. You probably don't have one. So you should be careful about setting your numbers that big. This is a very pessimistic estimate because a lot of these buffers aren't always allocated and some of them aren't allocated to full size. But in a worst case scenario, all 2,000 connections are open, they're running the right kind of query, they've used up all the buffers, you might be trying to allocate several hundred gigabytes of memory. There is documentation on the website that will tell you, which variables are used for what and that sort of thing. In most setups, you might use 1 or 2 megabytes per connection to keep track of various things. So that's something that you need to be aware of. Does that answer your question? Fantastic. It turns out this is probably our fault that this has happened. MySQL has shipped for quite some time with some wonderful example configuration files. They have some great names. We've got mysmall.conf. That's recommended for servers with less than 64 megabytes of RAM. Maybe a Raspberry Pi. We've got mylarge, and that's recommended for up to about half a gigabyte of RAM. And we've got myhuge for 1 to 2 gigabytes of RAM. These files shipped in MySQL 3.23 in April of 2003. That's now 10 years ago, about the same time I was in Perth doing a talk at LCA. And let's have a look at some of the settings that we get out of those files. So we can see as we go through the various files, in small we've got 4 tables we're going to cache, and we're going to have 64 kilobyte sort buffer and a 16K key buffer. As we get bigger, we've basically increased all the numbers. Our sort buffer size has gone from 64 kilobytes to a megabyte. And as we get bigger again, our sort buffer size is now 2 megabytes. So all these numbers are going up and up and up. And so this is what we had in 2003. MySQL 5.5 was released just last month. And shipping these files, and let's have a look what the current recommended settings are for these server setups. 10 years ago have gone on. We've now got 64 cores in servers and hundreds of gigabytes of RAM. And we still have the same recommended settings, and they still get bigger every time you get more RAM. I thought about making a graph, what happens if we plot 1 megabyte and 2 megabytes for 2 gig of RAM, and if we've got 128 gig of RAM, what that setting is, but I imagine it's probably 128 megabytes or something, which is not really optimal. We also at some point added a file called MyINNODB heavy 4 gig. And in that particular one, you can see they've got bigger again. So we've got join buffer sizes of 8 megabytes and 16 megabytes. So if anyone looked at these files, they could reasonably conclude that bigger is better for these numbers and we should just increase them all. We're sorry for that. These have now been removed. So as of MySQL 5.6, which has been released in the last year, they got rid of these files, thankfully. So don't look at these files. If you see these files, delete them, burn them, whatever you need to do, just pretend that they don't exist. So based on all this, I've come up with my recommended #1 optimal MySQL configuration file. It looks like this. MySQL gets upset if you try and run it as root, so we tell it to run it as the MySQL user. Other than that, everything else is a default. That's probably not too bad. We are going to adjust a couple of those, but the key lesson here is to avoid excessive tuning. Don't obsess over every single variable that you can change. Yes, there's 100 of them. You only really need to change 4 or 5 of them. Is there anyone here now that feels guilty because they know that they've got 8 megabytes in their join buffer size somewhere? Yeah, a few of them. You're not alone, don't worry, everyone else does too. A quick talk about system specifications that are ideal for MySQL. Multi-core is good. MySQL 5.5 and 5.6 have now gotten very good at servers with 16, 32 cores. That wasn't the case in earlier versions, so if you saw some problems there, it's a lot better now. And get as much RAM as you can afford. MySQL loves RAM, databases love RAM. RAM is much faster than disks, even SSDs. So SSDs are great, but RAM is faster than SSDs. A couple of bits of system information we can look at to maybe get some idea, are we having some problems on our server? MySQL has a wonderful command called the show process list. So this will show you basically all the queries running on the server, what they're currently doing, what state they're in, and how long they've been running for. You can often get some very good information about what's happening on your server just from this command. If everything says sleeping, that's great, your server's doing no work. That can also be a misnomer, because even though it says sleeping, it turns out that for 1 millisecond out of 1,000, all those connections run a query, and it's actually quite busy. You just can't see it at the moment that you run the process list. So that's something to be aware of. Linux has some great commands like vmstat and iostat, and you can see from these information such as the amount of swap being used. If your system is using swap on a database server, that's a pretty bad sign. Or more importantly, having a bit of swap in use is not bad, but if it's constantly swapping stuff in and out of swap, you're probably using too much memory, and it'd be much more efficient to let the database actually figure out which data it's going to take in and out of disk. And we can also see some CPU usage and that sort of thing from here, so this is a good command to look at. And the other one is, top is remarkably insightful. It's only got some very basic info, but it can be very helpful in just getting a rough idea. Is your system using a lot of CPU? Is it using a lot of RAM? And most importantly, the one I like looking at is there something else above MySQL using lots of RAM or lots of CPU? And so that's usually a good idea of, can I use all this system's resources for MySQL, or are we actually sharing something with something else? So if you're a sysadmin of your own server, you probably know the answer to that. I have the misfortune of having to sysadmin everyone else's server, so I need to figure these things out. Because most of the time you ask them, are you doing anything else? They're like, no, it's just MySQL, you can use it all. And then you look in the process list and there's like, 10 Java processes, 3 copies of Apache, and lots of things you need to worry about. Does anyone have any questions so far on what I've talked about at all? I invite anyone to, if they're unsure about anything, or, yes, question.
You turn those lights off so that we can read the slides.
Sorry? Oh, the lights, I see. They're a bit bright. Do you guys know at all about the lights? I presume it's on here somewhere, maybe? Lights, there's a button that says lights. Down lights, down. Oh, that's better. Main lights, 50%. Is that better? Hey! We can go further if you like. Hey, look at that, that's great. Doesn't that red look absolutely wonderful like that? Any further questions about the room lighting? Yes?
Will you make the slides available?
The slides absolutely will be available. You'll be able to get them either from my website. If you search Trent Lloyd, you should find that. But they should also be on the conference website, I imagine in the next week or so. But I will put them up on the website at just this afternoon, and I'll put that address up. If you ask me at the end, I'll give you the address. Great, so I'm now going to go through a few of the settings that you should probably look at changing and that you might need to be aware of and that you might have seen around. The first one we already talked about a bit, that's max connections. So most people find the default of 150 is not enough and they need to raise it. The key thing here is just to be very careful about how high you set it, because usually what happens is for some reason the MySQL server gets stuck. Maybe your disk goes away and all of a sudden all of your applications are trying to connect and it'll actually use up all 1,000 connections waiting for a query to run, waiting for the disk to come back to it. So even though you think setting it to 1,000, you probably never use them, it's those sorts of error situations that usually cause that. And then what happens is even though your disk froze, you end up using all of your RAM and you think that you ran out of RAM and then you kind of miss the original problem. So try and set it to some kind of sensible value. You can look at this max used connections value with show global status to try and get an idea of how many connections you've been using. The table cache is another one that we have in MySQL. So every time a query makes use of a table, it opens a copy of that table. So it doesn't matter whether you've got one table. If there's 10 queries accessing the same table, they're going to open 10 copies of that table. And opening those tables is a fairly expensive process. You've got to open the file on disk, you've got to do some locking, and generally just get that table open. So what it does is it keeps a cache copy of these tables around so that if another query needs to use that table, it can just grab it out of the cache and it saves that startup time.
Copy table or copy schema?
Both, actually, which we'll see in just a moment. Sorry, the question was, is it looking at the copy of the schema or the table itself? And the answer is it actually has to open both. So we can use show global status. We've talked about this command to actually have a look at this information. And so there's two kinds of ways we open the table. The first is to get the table definition, or if you know MySQL, you might know that as a FRM file. And that comes up under open table definitions and opened table definitions. And so what these two variables are telling us, or two status values, is open table definitions tells us how many are open right now, whereas opened table definition tells us how many times has the server opened a table to get its definition. And so we want to look at that ratio. If you see an open tables definitions of 5 million, unless you have 5 million tables, most likely it's constantly opening and closing tables to get a new copy of them, and that's a sign perhaps you could increase the amount of table definitions you're caching. Same goes for actual table copies that you keep open. This server is a terrible example. So we've currently got 64 tables open, but it's opened a table 503,000 times in some period of time since the server started. I know this server only has maybe a couple hundred tables, so it's constantly opening and closing tables and switching between them. So this is a prime example where we can think, well, we can probably increase that table cache so we don't have to spend so much time opening and closing tables. Now, this server may be running perfectly fine. It may not be obviously slow, but if you've ever seen this in a process list, has anyone ever seen this sort of information in a process list saying opening and closing tables? We've got one web hosting provider here that has, and a couple others. So there's several reasons that the server can be stuck in opening and closing tables, but a pretty common one is that it's trying to open the table, and if it had a one that it could get out of the cache, it would have sped that up. So this is a clear example that you might be actually having trouble with this. On this particular server, it doesn't really have any problems opening tables. It's got enough spare resources to do it, but we can see that most certainly it could benefit from having them in cache, even though it still has enough resources. What's a good number for the table cache? It depends exactly on your server. So the two things mainly to keep in mind are the maximum number of connections the server is going to handle. So that might be, say, 100. And then the number of tables that any connection is going to use in a short period of time. The defaults for this is actually quite high in MySQL 5.6. They've gotten a lot better than in earlier versions. It's set to about 2,000, depending on your system setup. But if you maybe have a system that has tens of thousands of tables for some reason, maybe you're running 100 Moodle instances, then you might want to increase these to maybe cache 4 or 10,000 tables. There isn't usually too much of a downside to this. It does use a little bit of RAM, but other than that, you're pretty good. Anyone have questions on the table cache at all? Great. So the next cache that we can look at is the thread cache. So under MySQL, every time you make a connection to the server and every connection that's active to the server uses one thread just for that connection. This has changed a little bit. MySQL in the enterprise version has a plugin that changes how this works, and MariaDB has a way of changing how this works. But in most servers, you're likely to look at, if you've got 100 connections, you've got 100 threads. And starting a thread is reasonably expensive if you have to do it continuously, maybe if you're doing hundreds of thousands of connections a second. So MySQL can actually cache those threads for reuse next time a connection comes in. So we can have a look at the status, threads with a wildcard, and we see the number of times we've created a thread and the number of connections to the server. And so we can look at that as a ratio, much like how many times we have opened a table versus how many tables we have. We can say, well, if we've had 144,000 connections to the server, and every time we had to create a new thread, that's a good sign that we could probably make that thread cache bigger. In this case, the thread cache is set to 0, so every time someone connected, we created a connection. This server doesn't get many connections, so it's not a problem, but if every time you hit your website, it opens a new connection and you're getting 100,000 requests a second, that definitely becomes to start a little bit of a problem. So the thread cache is one that we can set. The main downside of increasing it is you're going to use more memory. So every thread, when it's created, has maybe 500 kilobytes to a couple megabytes that is going to be in use. So if you keep 1,000 in the cache, you're going to be using a few gigabytes of RAM just for those, even when they're not in use. But otherwise, the answer is going to be somewhere between 0 and the maximum number of connections that your server will be handling at any one time. So that's to talk about the couple main of the little caches we can set. There are lots more of them, but they're the only two you're likely to have a problem with. Moving on to some of the buffers that are actually used for caching data in memory. MyISAM and InnerTV are two different storage engines in MySQL. Is there anyone here that does not know the difference between MyISAM and InnerTV? It's okay if you don't. Just a couple. That's cool. So basically, MySQL is a server with an SQL interface, but on the back end, it can store that data in different places. And so MyISAM was the first storage engine MySQL came with. It's non-transactional. You can't make several changes and roll them back, and it's not crash safe. So if the whole server gets powered off halfway through a query and it's updated half the rows stay updated and half of them don't. MySQL later on introduced an engine called InnerTV, which was originally developed externally. And that has crash safety and ACID compliance that we sort of expect from database systems nowadays. So if the server starts an update, it's updating 100,000 rows and gets halfway through that update, once the server starts back up again, it knows about that and it can then roll those back and get the server back to a state of either the query happened or it didn't happen. That's a basic rundown, the difference between InnerTV and MyISAM. So if you are using MyISAM, there is a variable called the key buffer size, and this is how much memory the server uses to cache table indexes in memory. One thing to realize, even if you're using all InnerTV, which people often do now, the MySQL system tables, which store user permissions and store procedures and a few other things like that, are still MyISAM tables. So you do need to keep something in your key buffer size. So don't set this too small. The default is 8 megabytes. That's likely plenty if you don't have any MyISAM tables yourself. But if you actually have hundreds of megabytes of data in MyISAM tables, you'll most likely want to increase this key buffer size. And that way it'll keep more of your indexes in memory. So the key buffer size is one we changed for that. It's important to note, MyISAM uses the operating system file system cache for caching the actual data in the tables. It only has a sort of internal cache for the table indexes. So much like everything else we've looked at, we can take a look at the current status and what's happening with the key buffer in memory. So there's a couple of main things to look at. The first one is the key blocks used versus unused. So this tells us of the buffer that we've allocated, maybe 8 megabytes, how much of that is currently actually in use. On this server, that's not very much. It's only 7 out of 7,000. And then we can look at key reads versus read request. So when you want to read through an index in a table, the server makes a read request for that table, and if it's in the key buffer, it just gets immediately returned out of RAM. If it actually has to make a request to disk to read it, it then shows up under key reads. So if your server didn't have a big enough key buffer, and it had to keep going to the disk to find all the indexes, you'd find that this key reads value would be very close to key reads request, because it never managed to satisfy it from the cache. So you basically need to combine these two status variables to determine, do I need to make it bigger? Even if every single read that you did wasn't cached, if you're only using 7 out of 7,000 blocks in the key buffer, there's no point making it bigger because it's not going to be used. But if the key buffer is full and then you find it's not being read from the cache from these two variables, then we know that we maybe need to set that bigger. Question?
Is it cheaper to use MyISAM or something? Like, why do they use it for user data and not for the other?
I'm hoping that's going to change soon. There was plans in the works to basically perhaps moving to it. It's just a legacy thing that's left over. So MySQL stores all of its user data in MyISAM, mostly because it always has. I suspect that's probably changing soon. But when that happens, I'm not entirely sure. And a lot of people are still using MyISAM as well, mostly for legacy reasons. But InnerTV is pretty much the sole choice most people make if they're sort of starting fresh. If you are actually using InnerTV, it has a similar mechanism called the InnerTV buffer pool. And the buffer pool actually stores both data and indexes. So all the data in InnerTV is stored in the buffer pool. And letting MySQL manage that in memory versus relying on the file system cache lets it be a little bit smarter about what data it keeps in memory. And the way InnerTV works, it also keeps changes to those pages in memory as well. So having this set big enough is quite important. So if your database server maybe has 8 gigabytes of RAM and it's purely a database server, you don't have to worry about anything else. As a terribly bad rule of thumb, you might want to set this to most of your RAM, maybe 75 or 80%. The main thing that would change that is how many connections your server needs to support. So if you need to support 2,000 connections, you're going to have to leave off RAM to handle those actual connections. This is probably the #1 most important variable to change in MySQL servers. So the default value for this is 128 megabytes. And in most cases, it really should be a few gigabytes so it can keep all of your data cached. This is the status information we can get about the buffer pool. So much like we just looked at with the MyISAM key buffer, we have a reads versus reads request value. So we can see on this server there's a very large number of times we've attempted to read data. I'm not sure what that is, maybe 1.8 billion. The number of times it actually went to disk is much smaller, only maybe 6 million. So that's a good example. That's what we want to see. Not many reads actually going to disk. And we can also look at how many pages there are total versus actually in use. So we see in this case there's no pages free. So the important thing to realize here is there's no pages free. That doesn't mean we need to increase the size of the buffer pool because the efficiency is actually very high. If we look at the number of times we had to read from disk, it was only about 0.3% of the time. So this size is perfectly fine, don't need to make it bigger. But if we found that hit rate was low and it was all in use, then we might need to make it bigger. Does anyone have any questions surrounding that? Or does that make sense? Cool. So yeah, this is the biggest one to remember, InnerTV buffer pool. It's probably the one that maybe could auto-scale, but as I explained before, you don't know maybe how much other memory the system needs. So it's not the simplest question to ask, what should we auto-scale that memory to?
Or it could be dynamic in a chain, right? Another MySQL server starts up, 3 months into the old one, right? And all of a sudden, the whole system's got to have enough RAM to cope with all the MySQL instances that every time starts on that machine.
You mean like if you got 2 starting on the same system?
Well, if you start off with one, but 3 months later, one machine from HA plus to crashes.
Yep. So the statement was, you might have a system running MySQL that only runs one instance, but due to some kind of failure, you started up a second instance on that server, maybe automatically or manually, and all of a sudden you need half of the RAM for that instance. So that's a case where it would then maybe be using too much. So you might want to specifically configure the server to have half. Although you could argue that's a case where you could configure it manually specifically or whatever, but yeah, it's just not the easiest question to solve is the answer. The next big one to look at is the query cache. Is there anyone here that's ever had problems with the query cache that they know of? We've got 1, we've got 2, we've got 3. What was the problem that you had?
I've got one instance where the query cache keeps on getting flushed.
Keeps on getting flushed?
Yeah.
Okay.
I got a high level query cache flushed.
Okay, so what was your name, sorry?
David.
So David has a problem where the query keeps getting flushed. I think more what you're saying is they keep getting invalidated from the cache before they're used. Is that right?
I guess so.
Yep.
I'm not entirely sure.
Okay. Does anyone else have a different situation, maybe where they had a problem? Nope. Okay, so the query cache is a mechanism in the server which takes the literal text of the query, like the actual text, and it hashes that text, and it stores against that the exact result set that came back. So you've got your SQL query, and you've got the exact number of rows that were sent back to the client. This is designed so that if you have an application that is either silly or is distributed, and it runs the same query over and over again, rather than performing all the work of the query, it can simply get the result straight out of the cache. I understand it was originally implemented because a particular benchmark was doing this, but you see this a lot with web applications. So, someone comes into a website and hits the front page, and every time they hit the page, they query for all the news items, or maybe they get their own session. So the query cache can help here by, at a server level, caching that information and not having the application have to worry about it. The problem with this is the bigger it gets, every time you run a query that changes data, you've got to look through the entire cache and figure out which items now need to be invalidated because I've changed some data. So you've cached the news items on the front page, and then your publicist comes in and adds a new news item. We now need to go through and invalidate every item in the query cache that looks at those news items. And MySQL isn't particularly smart about this. It basically scans it one end to the other. So the problem is people like to set the query cache to a very big number. Maybe, sorry? Got to wrap up? All right, not a problem. So it sets the query cache to a fairly big number, and then it starts spending sometimes a second or more invalidating all those results in memory. So this is one you've got to be careful. Basically, 64 megabytes is pretty much the maximum number you want to set this to. If you've got hundreds of megabytes or a gigabyte, that's bad. You need to get rid of that. And I believe I am out of time. So, quick summary. All the way to the end. Thank you very much. Do we have time for questions, or did I run through that as well?
Run through that.
That's all right.
Thank you.
Thank you. I hope that helped. If you want to come see me, happy to talk to you.